All right, so here is the video on combustion and neutralization reactions. So I'm going to talk about combustion reactions first. Essentially, what is a combustion reaction? It's a chemical reaction where you burn something. And the only way to really burn something is to react it with oxygen. And in this case, we're going to be talking about complete combustion. So whatever you are starting with, you are going to be reacting it with oxygen to burn it, and you are going to make the products of carbon dioxide and water. So we call this complete combustion because all of this molecule will become carbon dioxide and water as the waste products. So you're going to start with some sort of a hydrocarbon. What is a hydrocarbon? Something that has hydrogen and carbon in it. And we tend to see these formulas written as like CXHY because it can be any number of carbons combined with any number of hydrogens. So like C3H8, that's a hydrocarbon. C6H12O6, that's glucose, but that's still a hydrocarbon. CH4 is methane, that's a hydrocarbon. So all of these, C4H10, they're all hydrocarbons. And you can burn them by reacting them with oxygen. And the cool thing is, you always get the same products. You always get carbon dioxide and water. So it's really easy to predict the products on these because you always get the same ones. So yeah, basically that's all it is looking at going, oh, cool, there's a hydrocarbon reacting with oxygen. Here's what I'm going to make, carbon dioxide and water. And then you have to go back and balance it. These might be the easiest to write the products for, but they are the hardest to balance. And my advice to you would be just start balancing the carbons first, then do the hydrogens, then do the oxygens last. If you end up with a half or a number that's not divisible by 2, like if you end up with 13 oxygens on one side, multiply everything by 2 to get it to a number that is divisible by 2. So those are combustion reactions. Neutralization reactions are a specific type of double replacement reaction. So they are a double replacement because you are starting with 2 compounds, and your 2 compounds are going to be an acid and a base. So whatever acid you're starting with, your acids are always going to have hydrogen in them, and in this case, your bases are going to have hydroxide in them. So the examples that they give you, like this one right here, that they work out for you, where they give you HC2H3O2 plus NaOH. So this is my acid because it has a hydrogen with it, and this is my base because it has the hydroxide with it. And what happens here is, since it's a double replacement reaction, the nonmetal parts, the negative parts, switch places. So now sodium is going to bond with, sodium is a 1 plus, and then acetate, C2H3O2 is a 1 minus, so sodium acetate. And then the hydroxide and the hydrogen join together to form water. And that's why it's a neutralization reaction. They give you some examples like this one right here of HBr, which is hydrobromic acid, plus aluminum hydroxide. The bromine and the hydroxide switch places. Those are both the negatives or the nonmetals, the anions in that compound. So aluminum is now going to bond with bromine. Aluminum is a 3 plus. Bromine is a 1 minus, so I need 3 of the bromines, plus HOH, which is H2O. So you're always going to make water. That's what makes it neutralization. And then you form this salt, this ionic compound between a metal and a nonmetal, or between something that is positively charged and negatively charged. So that's kind of the way to identify them. They're a double replacement reaction where you have a hydrogen and a hydroxide, and then you always are going to have a product of water. That's what makes it neutralization.